And now that we've talked about stoichiometry in Chapter 9 and gases in Chapter 7, or whatever chapter your book says, you may be using a different book, we can relate the two in a way to talk about a kind of a historical thing, but I've seen a question on standardized tests before. If we know the mass of a gas and its the number of moles in the gas, we can easily find the grams per mole, the molar mass of the gas. So here's the stoichiometry. I react some hydrochloric acid with some iron sulfide, creating a stinky gas, but I don't quite know what the formula is. I mean, I do, but I'm not saying, I'm pretending I don't. But I do know that 1 part of iron sulfide leads to 1 part of stinky gas, 2 parts of HCl. If I started with 5.86 grams of iron sulfide, and I knew somehow that I released 2.272 grams of unknown stinky gas, what's the molar mass of the gas? Well, let's do it this way. Should we compare change grams of iron sulfide to moles of iron sulfide, compare moles of iron sulfide to moles of unknown gas, and that's a 1-to-1 ratio. Then if I know the grams of unknown gas, I can pretty simply find the molar mass of the unknown stinky gas. So 5.68 grams of iron sulfide changes to moles of iron sulfide. It's a 1-to-1 ratio of the stinky gas to the iron sulfide. So it's this one divided by this one gives me 0.067-ish moles of stinky gas. And if I somehow knew also from experiment from the lab that mass of gas was 2.272 grams, I could probably find the molar mass of the gas. Oh yeah, so here I'm telling you the answer. It's 32 plus 1 plus 1 is 34 grams for hydrogen sulfide gas. It's a stinky gas. It's poisonous, but we're pretty sensitive to it, and the moment we smell just a little bit of it, we run the other way. Dang, that stinks. There's another twist on this that's involving the molar mass, grams per mole, and the density. Density? Density, density, density. Density, we never talk about density. Way back in chapter 1 we did, but it's a kind of a useful tool, I suppose, if you're talking about measuring gases in grams per liter. So gases are different. They're in grams per liter because they're about 1,000 times more spread out than liquids and solids. But in any case, it's a relatively simple conversion to change PV equals nRT into the ratio of pressure to RT, PRT, gas constant, Kelvin temperature. The number of particles, another name for the number of particles is the mass in grams divided by the molar mass. So if I, in a sense, put the molar mass as a capital M right here, the density is of the gas in grams per liter, which is mass per volume, is the molar mass times the pressure of the gas and the Kelvin temperature of the gas constant thrown in there as well. That's kind of a nice one to memorize if you can. I know you can if you have the time and fortitude. So in this question, talking about carbon dioxide gas, and they want to know the density at 788 torr and 25.5 Celsius. Well, we got to change the torr to atmospheres because the gas constant is given in atmospheres. We probably should change the Celsius to Kelvin because, again, it's the absolute temperature scale. And lo and behold, just chug the numbers in. 44 grams per mole for CO2, 1 carbon, 2 oxygens add up to 44 grams. Change millimeters of mercury into atmospheres, change Celsius into Kelvin, chug the numbers out, 1.86 grams per liter. Normal air is about 1 gram per liter, but carbon dioxide seems to be heavier, yeah? Oh, that's interesting. I wonder if you could try that. You could try that if you wanted to pause the video right now. 5.63 grams of gas released into a volume of 3.75 liters. The pressure is 0.835 atmospheres. Temperature, what's the molar mass of the gas? Molar mass. Well, I suppose I could use that equation. I remembered the density is molar mass times the pressure divided by the gas constant and the Kelvin temperature. Or ways to work it out as well, but if you feel like pausing the video, I would. At some point you'll need some practice with this. No time like the present, they always say. Or if you're lazy right now, let me give you the answer. Yeah, I use this one. Number of particles, pressure, volume, gas constant, temperature. So I found the number of moles of gas, and the molar mass then is just the grams divided by the moles. Oh yeah, what? Acid plus carbonates. Why did I say that? Reaction between an acid and a carbonate. Oh yeah. So what's an acid? What's a carbonate? An acid has an H plus ion. A carbonate has the carbonate ion. And this is an interesting and fun reaction when you just do baking soda and vinegar. Baking soda and vinegar, vinegar and baking soda. It's actually endothermic, curiously, interestingly. It gets colder and forms a whole bunch of stable water molecules and a whole bunch of carbon dioxide gas molecules. Alright, time to shut up. Thanks, guys. See you soon.